Hello everyone, this is part 3 video of lesson gravitation class 10 science 1. Okay, so student, in our previous video we have already discussed various laws related to modern periodic table and structure. We have already also discussed structure of periodic table. All right, so in today's video we will discuss the periodic table and electronic configuration of elements. Okay, so I hope you all know what is the periodic table and what is the structure of the periodic table. So let's discuss this periodic table and electronic configuration of the element. Okay, first of all, what is electronic configuration? So this is a distribution of electron. Okay, distribution of electron in a period, like for suppose we can take an example of sodium. Okay, and sodium element. So in sodium, 11 atomic number of sodium is 11, so the electronic configuration will be 2 8 1. Okay, that means in first shell 2 electrons will be there, in second shell 8 electrons will be there, and in last shell or valence shell 1 electron is will be there. So this valence shell 1 electron is there, so this is called as a valence electron. All right. Okay, now with student, within a period, now I hope you know what is a period. Sorry. Okay, so there are vertical columns and horizontal rows. Okay, so the vertical are called as a group and the horizontal um, lines are called as a period. So within a period the neighboring element like this, like we will take the example of third period. Okay, so neighboring element like sodium and magnesium differ slightly in their properties. Okay, properties like physical and chemical properties, while distance element differ widely in their properties. So within a period the properties will be, they will differ in slight differ will be there, slight difference will be there in their chemical as well as physical property. Okay, so elements of a same group, now we are talking about groups like this, group 1, group 2, and here group 18 is there, group 17 is there. Okay, so elements of same group, so elements of, these are the groups. Okay, verticals are the group. So elements in the same group show similarity and gradation. So it shows similarity and gradation, similarity and gradation in their physical and chemical properties. So these characteristics of groups and periods in the modern periodic table are because of the electronic configuration only. Okay, and it is the electronic configuration of element which decides the group and period in which it is to be played. So it's all about the electronic configuration of the elements. Alright, now let us discuss groups and electronic configuration, vertical groups. Okay, we have total 18 groups in a modern periodic table. So student, here I have taken example of elements. Here I have taken elements of group 1 which are known as alkali metals also. Okay, so in group 1 we have lithium, sodium, potassium, rubidium, cesium. Okay, so these are the elements of group 1 which are alkali metals. So here below the element I have written atomic number of each element. Lithium 3, sodium 11, potassium 19, and rubidium is 37. Okay, now electronic configuration. Now just observe the electronic configuration of the element. Lithium is having 2,1, sodium 281. Like here 3 shells are there. In lithium we have 2 shells, sodium we have 3 shells, potassium 4 shells are there, and in rubidium we have 5 shells. Okay, so here you can observe that the valence electron, that means electron which are present in a last shell or valence shell will be same. Okay, so these are the same in alkali metal. Now just discuss about group 2. Group 2 we have alkaline earth metal. Okay, alkaline earth metal like beryllium, magnesium, calcium, strontium, and barium, etc. Okay, so beryllium atomic number is 4, magnesium 12, and calcium 20. Here I have taken only 3 elements. Now just observe the electronic configuration. Like here, electronic configuration of beryllium is 2 comma 2. Okay, again 2 shell, 3 shell, and 4 shell. Now just observe the valence electron in each element. So valence electron of group 2 is 2. Okay, now just look at the halogens. Halogens are from group 17. Okay, so these are the halogens like fluorine, chlorine, bromine, iodine. Okay, all right. Now I have written 3 elements from group 17: fluorine atomic number 9, chlorine atomic number 17, bromine atomic number 35. Okay, so just like above groups here, electronic configuration of fluorine 2 comma 7, that means 2 shells, 3 shells in chlorine, and 4 shells in bromine. Again observe what is this? The valence electron is same. Okay, just so we can say here only one shell is getting added in each of the group, like in group 1. Okay, in each of the shells, but in each of the elements, but number of valence electron remains the same. Okay, number of valence. So while going from top to bottom, in each group, within any group, one electronic shell gets added at a time. Okay, one electronic shells get added at a time, and from this we can say that the electronic configuration of the outermost shell, like last shell, is characteristic of a particular group. However, as we go down a group, the number of shells goes on increasing, but the valence electron remains the same. Okay, now periods and electronic configuration. Periods means this horizontal rows. Okay, like lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine, neon. Okay, now student, you will find on going through the modern periodic table, it is seen that like lithium to neon. Okay, here I have taken lithium to neon element, and below I have written atomic number of each element. Okay, now look at the electronic configuration. Student, you can see here lithium 2 comma 1, beryllium 2 comma 2, boron 2 comma 3. These are the number of electrons. Okay, distribution of electrons in a elements in an atom. Okay, so you will find here that valence electron are changes. Okay, valence electron goes on increasing like 1 up to 8, but number of shells remains the same. So these are the elements of second period. So you will find that the number of valence electron is different in these elements, and however the number of shell is the same. That means all the atoms having the two shells. Okay, not valence, two shells. And you will also find that while going from left to right, okay, while moving from left to right, like lithium to neon in third period, so sodium to argon in fourth period, potassium to krypton. So while going from left to right within the period, the atomic number increases by 1 at a time. Atomic number, like sodium having 11 atomic number, magnesium 12, aluminium 13, and silicon 14 likewise. So by 1 at a time, and the number of valence electron also increases by 1 at a time. Okay, so number of valence electrons increases and number of shells is the same. Now if you will look at the elements of third period, like sodium to argon. Okay, so what is this? Number of shells. Here only 3 number of shells are there. Okay, 1, 2 and 3. But number of valence electron are changes one by one, and atomic number also increases by 1 at a time. Okay, electron holding capacity. So the number of elements in the first 3 periods. Okay, first 3 period, like this first, second and third. These periods are is determined by the electron capacity of the shells and the law of electron octet. Electron capacity of the cells, that means in each shell how many electrons should be there. Like here I have made a electron shell distribution diagram of an element. Okay, so this is a nucleus of an element, and nucleus. So first shell after the nucleus, first shell is K shell, its capacity is 2 electron. Okay, second shell is L shell, third shell is M shell, and fourth one is nth shell. Now let's study the electron holding capacity. That means how many electrons should be there in each shell. Okay, now for here, for the electron holding determining the electron holding capacity, here we have formula which is 2n square. Okay, now n is the number of shell. Okay, as per the electron holding capacity of the shells, 2 elements are present in the first period and 8 elements in the second period. Now let's determine it. Okay, so here first shell, which is K shell, 1. Okay, this is a first shell, so here 2n square, that means 2 into n is 1, first shell, 1 square, it will be 2. So first shell in K shell, electron holding capacity is 2 electron will be there in this K shell. Okay, K shell contain 2 electron, like 1 electron and second electron. Okay, now let's determine it for L shell. L is a second shell. Okay, so 2n square formula will be 2 into n value is 2. Now 2 square, so it will be 2 into 2 square will be 4. So electron holding capacity of second shell will be 8. Okay, now for third, it will be 2 into 3 square, so 2 into 9. 9 to the 18. Now for similarly for n shell, value of n is 4. 2 into 4 square, which is 2 into 16. That means here it will be 32. Okay, so as per the electron holding capacity of the shell, two elements are present in the two elements are present in the first period. Two elements like hydrogen and helium. Okay, and 8 elements are in the second period. 8 elements in the second period, like from lithium to neon, there are 8 elements are there. And the third period also contain, third period from sodium to argon, so this also contain only 8 elements due to the law of electron octet. Okay, and there are few more factors which control the filling of electron in the subsequent periods, which will be considered in later on. Okay, all right, now what is this law of electron octet? Students, the tendency of atom to have 8 electrons. Okay, octet means 8 electron, tendency of an atom to have an 8 electron in the valence shell. This is a law of electron octet. Now next topic is periodic trends in the modern periodic table. Okay, now when the properties of elements in a period or a group of the modern periodic table are compared, certain regularity is observed. That means certain characteristics like physical and chemical properties are repeated, or similarities is observed, not similarities, it is repeated after an interval of time, is observed in their variation. It is called as a periodic trends in the modern periodic table. Okay, so here we have to discuss the 3 characteristics. First one is valency, atomic size, and metallic and non-metallic character. So in this video we will discuss only 2 characteristics, which are valency and atomic size. And third property, which is metallic and non-metallic character, we will discuss in later in another video. Okay, valency, what is it? Valency of an element is determined by the number of electron present in the outermost shell. Outermost shell means valence shell, okay, of its atom, that is valence electron. So if we will take an example of potassium of fourth period and first group, so in potassium atomic number is 19. Okay, and the electronic configuration of potassium is 2881. So here 4 shells are there, and the valence electron means the electron which is present in the outermost or last shell or valence shell. This is called as a valence electron. Okay, so here we will also say that valency of an element. Okay, like in octet we have 8 electron, right? So 8 electron I am writing here. Okay, so 8 electrons are there total. Okay, now we will distribute it like from 1 to, okay, 1 electron, the elements which contain 1 to 3 electrons, okay, in their last shell. So the valency will be equivalent to the number of valence electron. Valency will be equivalent to number of valence electron in that particular element. Like if we will take an example of potassium, so potassium last shell 1 electron is there, that means the valency of potassium will be 1. Okay, But if an element having 4 electron like carbon, okay, carbon atomic number is 6. That means electronic configuration of carbon will be 2 comma here 6 now, okay, 2 comma 4. So carbon having 4 electron in its valence shell or outermost shell. So the 4 electron, so carbon will share 4 electron to form a bond with another element, okay. So it will share 4 electrons. So valency of a carbon will be same, which is 4. Okay, this is valency. Valency of a carbon will be same. Okay. Now next is here 1 up to 3. The elements, these elements were lose electron. Okay, these will lose electron to the another atom to form a bond. So the valence remain same as the valence electron. Okay. Now we will look for 4 also. Now if the element contain 5 to 8 number of electron in its valence shell. So here the valency will be, what will be the valency here? Here the valency will be number of electron the element will accept to form a bond with another atom. For example, if we will take an example of fluorine. Okay, so here fluorine atomic number is 9 and electronic configuration of fluorine will be 2 comma, okay, here fluorine electronic configuration is 2 comma 7. That means fluorine required one more electron to complete its octet. Okay, by accepting one electron its electronic configuration will be 2 comma 8, so it need plus 1 electron. Okay, so the valency of the fluorine will be plus 1. So here if 5 electron are there in last shell or valence shell, so here it this elements required 3 more electron to complete it octet state. So the valency will be 3. Okay, but if an element having 6, if an element having 6 and 7 6 and 7 electron in its valence shell, so valency will be number of electron it will accept to form a bond with another atom. Okay, so I hope you all have understood the concept of valency very well. Let's move on. Okay, next topic is atomic size. So what is atomic size? Okay, the size of an atom is indicated by its radius, and atomic radius is the distance. That means atomic size is the radius of an atom. Okay, so atomic radius is the distance between the nucleus of the atom and its outermost shell. Nucleus of an atom and its outermost shell. For suppose we will take example of potassium. Okay, potassium, this is nucleus of an potassium. First shell of a potassium contain 2 electron. Okay, now second shell of potassium is contain how many electron? 8 electron. Okay, 1 2 3 4 5 6 7 8. Okay, now third shell, again third shell, here I am not drawing the electron. Okay, this is first shell, second shell, third shell, and last shell is the valence shell which contain 1 electron. So what is the atomic radius of the potassium? It will be the distance between the nucleus. Okay, distance between the nucleus, that means distance from nucleus to the nucleus and its outermost shell. Outermost shell is this much. Okay, so this is the atomic size of particular atom. Distance between the nucleus and the outermost shell is called as a atomic size. Okay, so atomic radius is expressed in the unit picometer. Okay, picometer, which is pm, short form it is pm, which is smaller than the nanometer. And here we have one conversion, that is 1 picometer is equals to 10 raised to minus 12 meter. That means this picometer is smaller than nanometer also. The value of nanometer is 10 raised to minus 9. It is for nanometer. Okay, all right, now let's understand some atomic size for periods as well as for groups. Okay, all right, now here the atomic radius for left to right, that means we are talking about a period. Okay, now left to right, like here I have taken example of oxygen. It oxygen for okay, left to right, that means from lithium to Okay, from lithium to oxygen. All right, lithium to oxygen. Now here in second year, these are the elements of second period. Okay, these are the elements of second period. Now in second period, we have first element as lithium. Okay, first element is lithium. So lithium atomic radius is 152 picometer. Okay, now second element of second period is beryllium. So beryllium atomic radius is 111 picometer. Okay, after beryllium we have boron. Okay, so these are the unscrambled elements I have written. Sorry for that. Okay, so third element is boron. So boron atomic radius is 88 picometer. And after boron we have carbon. Okay, after boron we have carbon here. So for carbon atomic radius is 77. Then after carbon, nitrogen atomic number is 74. And then last we have oxygen, which is 66. So student, if you will look clearly properly here, so first element 152. Okay, I am writing here. For lithium it is 152, then beryllium 111. After beryllium we have boron, which is 88. Then after boron, carbon 77. Then nitrogen, which is 74. Then oxygen, finally it is 66. Okay, so as we were moving left to right, okay, so from left, first element is this beryllium, lithium, then lithium to oxygen. So as we were moving left to right, you will clearly observe that atomic radius goes on decreasing. Okay, so here atomic radius goes on decreasing. Why? Because here certain reasons are there. So the reason behind this will be, while going from left to right within a period, the atomic number. Okay, so the atomic number, what about this? Atomic number increases one by one. Atomic number increases one by one, meaning the positive charge. If atomic number increases, means positive charge increases. All right, positive charge increases on the nucleus one by one, and however the additional electron gets added to the same outermost shell. That means here our number of shell remains same, so the additional electron will be added to the same outermost shell, and due to the increase in nuclear charge on the nucleus, the electrons are pulled towards the nucleus to a greater extent, and thereby the size of the atom decreases. So from left to right, atomic radius goes on decreases, because nuclear atomic number increases, nuclear charge also increases one by one, and thereby decreases the atomic radius. Okay, now next one we will observe for the groups, that is from top to bottom. Okay, all right, so these are the element of group 1 from lithium to cesium. Okay, from lithium to cesium. So look at here, the atomic radius of lithium. I have atomic radius of all the elements I have written below there. Okay, so just observe the atomic radius, lithium to cesium. Okay, so atomic radius increases not one by one, atomic radius increases from top to bottom. Why this is so? So while going down a group, the atomic size goes on increasing. Okay, 152 picometer, and cesium is having atomic radius of 262 picometer. So it goes on increasing. Why? Because while going down a group, a new shell get added. Okay, new shell get added. Lithium is having one shell, two shells, three shells, four shells, so increases one by one. So new shell gets added one by one, and therefore the distance between the outermost electron and the nucleus, this is a nucleus, and distance between the outermost electron and nucleus also increases, and therefore the distance between the electron and nucleus increases. Outermost electron and nucleus decreases, and as a result of this, atomic size increases in spite of increased nuclear charge. So student, that's all for today. I hope you all have understood.